Go.
Okay, so we're back with question 5. Yeah. What is meant by polymerization? Many monomers make polymers.
क्वेश्चन तो पढ़ लेते हैं.
By
वैसे I don't think क्वेश्चन में कुछ यूजफुल दिया हुआ है.
what type of polymerization is involved in hydrogels? Okay, let's see what a hydrogel is. Super absorbent polymers have 200 to 300 blah blah blah. Okay, compound K is mixed with sodium hydroxide in the presence of an initiator. So what happens is इधर से आपका या आपका बस यहाँ से वो बनता जाता है और यहाँ पे CO माइनस लग जाते हैं, ठीक है? Because this is an acid and this is a base.
What's the base?
Sodium hydroxide.
But how would it? But अपने आप से कैसे बनाएगा? Sodium hydroxide के साथ polymer थोड़ी बनाएगा.
नहीं, sodium hydroxide का polymer नहीं, CO माइनस बन जाता है, ठीक है? And then that CO minus of course can't react with itself. The main thing is formed here. I think the polymerization is addition.
Yeah, it's simply addition.
Describe the changes in chemical bonding during the polymerization of K. Changes in chemical bonding. So here this is sp3. The sp3 carbon. I think no, this is an sp2 carbon. This is an sp2 carbon. That goes in sp3 carbon.
So by double bond to basically double bond to single bond अभी उसका.
This is double to single, right?
And उसका obviously bond length भी थोड़ी सी बढ़ जाएगी because instead of two
also
bonds,
the changes that occur is that ये CO HCO minus बन जाता है.
pi bond news or basically that's all they want basically.
Single bonds.
New single. So it's literally that simple. That
acrylic acid is the common name of compound K. Okay, just a systematic name. Okay, systematic name banana. So this has 3 carbons. So this is
propenoic acid.
Yeah, propene.
But वो numbering से करनी पड़ेगी बस वो.
So this is 2-propanoic acid.
Well, in group is that one. Well, that's kind of obvious, but prop 1-ene.
Prop.
क्या लेकिन propene में आप जिधर से नहीं.
Prop. No, this is prop 2 because C gets preference. So this C gets preference. Oh. That means this is 1, this is 2, this is 3.
Sorry.
That means this is prop 2 propanoic. Okay, this is 1 propanoic acid. Propon 1 OIC होता है.
Prop 2.
Let's check because I'm not even sure that I did this.
They're like screw that. It's like बना दो भैया बस लिख दो कि propanoic acid है.
Always remember you have to separate numbers with letters by dashes. Okay, this is the rule. Draw the structure of at least 2 repeat units of the polymer in a wedge.
So addition polymerization बस उसका repeat unit 2 बना दो.
You get C the bar. This is 2 repeat units. Okay, now you need H here, CO minus here, H here, CO minus.
You're adding the CO minus because it's mixed with
COONA, not CO minus, COONA. So this is CO minus plus minus. Remember, you have added NaOH. ये बस याद रखना. The CC angle changes from it was 120.
Yeah.
Goes to 109.5.
So basically, trigonal planar to tetrahedral. Yeah.
It was trigonal planar. Trigonal planar tetrahedral.
Or you could write from 3 bond pairs to 4 bond pairs.
Yeah.
Like,
or sp2 to sp3, whatever you get. Okay. Draw a detailed diagram of a portion of the polymer you have drawn to explain how it can absorb a large amount of water.
क्या वैसे इसमें हमने
So
Na
what
लगा
happens
दिया.
is
हाँ,
कि
हाइड्रोजन बॉन्ड से ही आप वाटर एब्जॉर्ब करते हो.
ठीक है.
But then in fact this question comes a lot, you know, पानी कैसे absorb करता है, डायपर में कैसे यूज
You
करता
have C, so you have an O, you have O के ऊपर दो लोन पेयर पड़े हुए हैं, ठीक है, and then you have O, and इसके ऊपर भी दो लोन पेयर पड़े हुए हैं, क्योंकि ठीक है, this is a minus and then this is Na plus, ठीक है, so this moves, and you have H2O, so H O H, ठीक है.
Good.
This makes, and similarly this makes a again H O H, again lone pairs are essential, ठीक है, and then this also makes it with an O, ठीक है, lone ऑक्सीजन के दो सर, ये H, ठीक है, इसका
Sorry,
भी
but
एक H.
doesn't the hydrogen also have to be attached to a highly electronegative atom to form a hydrogen bond? Because वरना
Yeah,
hydrogen
yeah,
slightly positive नहीं होगा. हाँ तो
yeah.
होता है. So like basically the guys just remember कि for hydrogen bonds, uh, the hydrogen has to be attached with a highly electronegative atom, and then it's going to form a hydrogen bond with a highly electronegative atom. So both of that is important.
ठीक है, let's check how they made it. Yeah, this is CONA. Yeah, again, you have lots of the H's, yes. So lots of H's reacting with this. So we need hydrogen bond labeled, we did this. Water H bonded to O, to H bond, lone pair, right, lone pair का एक number है, ठीक है.
Slightly negative, slightly positive also important.
We did one thing wrong, we need an Na plus here, ठीक है, this is one mark. Again, the Na plus इधर से निकल जाएगा, ठीक है, ठीक है, this forms hydrogen bonds, ठीक है, तो ये जो Na plus है, this will form a dative bond with O, ठीक है, because something has to react with O as well, right? कुछ चीजें इससे react करेंगी, कुछ चीजें उससे react करेंगी.
Na plus पे dative bond किस direction में?
Oh yeah, O. Come on.
So why is it forming a dative covalent? Why isn't it just going ahead with the ionic? Like,
ये माइनस नहीं है, ये प्लस है, ये तो माइनस नहीं है. Again, this is remember, this is a positive ion, but this is not negatively charged to make an ionic bond.
अच्छा.
A student added 0.1 gram of polymer to 10 centimeter cube of aqueous copper 2 sulfate solution. So remember that this absorbs about 200 times the mass of its own water, ठीक है. So this will absorb all the aqueous copper 2 sulfate था, ठीक है. Aqueous copper 2 sulfate से water निकल जाएगा, that तो क्या मतलब anhydrous बचेगा, और anhydrous copper 2 sulfate, that means जो blue solution था वो क्या बन जाएगा, क्योंकि anhydrous हो जाएगा, तो I think copper 2 sulfate is white. Because this becomes a white solid. Yeah. Okay. Let's check.
Whoops.
Solution becomes paler and Cu2 plus swapped with Na. Okay. Solution becomes paler, doesn't go white.
I think we overestimated its absorption powers.
So let's go. This becomes paler.
And the reason for it becoming paler is एक तो copper substitutes with sodium, and sodium sulfate का acids कोई color नहीं होता. And the second reason is because वैसे ही थोड़ा सा पानी and all is being absorbed.
ठीक है. This is a functional group, so this is what double bond, alkene, and CONH2 is
amide. because you can form an amide by a carboxylic acid and ammonia. That's what's happened above, वैसे. Okay.
Let's see, that's इधर क्या हुआ है? Yeah. So everything is the same, but you have made an acid to an.
Say, so you added.
So you have added NH3, I guess.
Yeah.
So you add NH3. So NH. Yeah, and now you go from COONH4 to C. So ये dissociate करके यहाँ से एक O निकल गया, यहाँ से दो H निकल गया, तो H2O is formed. Yeah. So yes, the conditions necessary to reform K from L. ठीक है? So you need to add water to it. Excess water and heat, I think.
I would say just add aqueous HCl and heat.
Yeah, aqueous HCl. Yeah, that's it. Aqueous HCl मतलब water तो पहले से ही आ गया.
Basically, and the reason why we either use alkaline or in this case acidic conditions is because they catalyze the reaction. Reflux basically, but the heat, I think they usually get happy with that. Heat, yeah, or reflux basically.
Yeah, HCl and heat or reflux. You can't. You need to reflux. Okay, we go into proteins. How many different tripeptides can be made using one molecule of each of the? Okay, so you need 3 options for the first, 3 options for the first. You 9, okay? Because you can make. Okay, let me check before I say something. Okay, yeah, you can form glycer, val. Like you can 3 options for the first, 3 options for the second, 3 options for the third. You get 27.
Because all of them has an amine as well as the carboxylic acid, so they can really form whichever way.
Okay, we're off by 21.
Shit. What did we do? What did we do wrong?
Okay, so let's see what happens. So you start with a gly. Let's see what happens if you start with a gly. What can gly react with? This is an acid. It can react with a SIR or a val. Can it react with another gly? I think it can. Okay, no. Yeah, that's the thing. Oh, this has to be 1 mole of each of them. That doesn't mean I can't use 3 moles of one of them and 0 moles of the other two. That's what we made.
So basically 3 factorial.
So there's 3 chances for the first, 2 for the second. For those who understand this, there's 3 options for the first, 2 for the second, 1 for the third. If you don't, you can write down all of them, so you can get glycer, val, valcer, val, glycer, valcer, gly, and you get SIR, gly, val, and SIR, gly. Okay, these are the 6. You have 1, 2, 3, 4, 5. You can draw the tripeptide SIR, gly, val. Okay, so you start with the SIR, you get an OH, NH2, OH. Now that OH is going to react with gly. So gly का NH2 लग जाएगा. That means यहाँ N लगेगा, यहाँ H लगेगा. ठीक है. That H reacted with the OH and it went away.
As a form of water. Yeah.
O. ठीक है. अब again यहाँ O react करेगा इसके NH2 से. Okay, so you get an N. अब N के साथ क्या लगा हुआ है? N के साथ ये कार्बन है. ठीक है. कार्बन के साथ ये की दूसरी टांग पे एक O लगा हुआ है और एक. It's just you just have to connect all of them.
Yeah, we just forgot
the first part is gly. Yeah. This one was SIR and this was val.
And we forgot a hydrogen with the second end.
Within the tripeptide, which amino acid provides a hydrophobic side chain. Okay, hydrophobic side chain is when this is this part. So that's val. I think it's val.
Why do you call it hydrophobic? Is it like scared?
Hydrophobic is anything that like hates water. The only thing that like NH2 loves water क्योंकि lone pair पड़ा हुआ है. Oxygen loves water because lone pair पड़ा हुआ है, ठीक है. So anything which is like purely hydrocarbon, that's hydrophobic. Hydrophobic मतलब it's water, ठीक है. Avoids water.
सही है.
Right.
So like homophobic to hydrophobic.
Polypeptide chains can form bonds, giving energy proteins their secondary and tertiary structures using the tripeptide in number 2. Tripeptide in 2.
It can
Okay,
form
you have to use this.
hydrogen bonds to like it's
So
your
this is
go-to. Hydrogen bonds bonding is like your safe bet.
And the bonds that will form hydrogen here are the oxygens and the nitrogen. So the NH2, which is the NH, so this is the NH2 group and the OH double bond O group. Let's what other thing will form? ठीक है, और क्या formed होते हैं? Ionic bonds.
Ionic can be formed, I guess, because when the carboxylic acid just donates it entirely to the NH2.
Again, carboxylic or NH2 ही कर रहे हैं.
वैसे तो वैंडरवाल भी आप वैंडरवाल आप कर सकते हो अगर करना चाहो, लेकिन
so you can do any two of hydrogen bonds, which is COH or OH or NH2 or CONH2 or CO or anything you write is going to work. Basically कुछ भी कचरा लिख दोगे, it's still going to work. Ionic bonds which is NH3 plus and CO minus, so I should rather write NH3 plus. I think that's a better way.
Oh, हाँ, because then they will form. अच्छा, because ionic bonds में you need to form the ions first, and between them then फिर वो ionic bonding होगी.
ठीक है, so this is CO minus. I should have written this one. Let's move. Comparative and non-comparative inhibitors not in the syllabus. Electrophoresis diagram you can check out online. Let's move. How far an amino acid will travel straight to other factors? So
what on earth?
In the pH of the solution. Okay. One is the mass of the amino acid. ठीक है. जितना भारी होगा, it will travel less. ठीक है. And what else? The charge on the amino acid. ठीक है. जितना ज़्यादा charge होगा, मतलब if you have like 2 negatives, it will travel faster than 1 negative. ठीक है. The charge on the acid. If it's uncharged, then it's probably like the slowest. A number of analytical, what is meant by term partition coefficient? That's like KPC. Remember, that's like it's the ratio of the separation in separation into. Now this is what is important into. What are the two solutions called? Which don't mix with each other.
Immiscible.
Like oil and water. Immiscible, yeah, immiscible. Immiscible. This is immiscible. Is I think crucial. Just check this. This is the diagram. रट लो इसको, याद कर लो, कुछ भी कर लो. It's the ratio of the concentration. Oh, ratio of the concentration. In each of the two, each of the two immiscible solvents. Okay. Still not over for God's sake. Okay, let's see. So the partition coefficient of X between ethoxyethane and water is 40. ठीक है, तो KPC 40 है. A solution containing 4 grams of X dissolved in 0.5 dm cubes of water. You calculate the mass of X with 0.5 dm cube of ethoxy. So KPC is like X in ethoxy over X in water. I think it's the same, right? because it's between ethoxy and water.
Yeah, I'm not too sure ऊपर नीचे क्या आता है, but I think
They allow reverse ratio, although yeah, it's over ethoxy over ethane, right?
yeah.
The good bet is the following two, which I seem to remember. One is if they say between A and B, ठीक है, तो A को ऊपर रख लो और B को ऊपर रख लो, ठीक है, तो यहाँ इन्होंने ethoxy और water का है, तो ethoxy को ऊपर रख दो, water को नीचे रख. The second good bet is remembering that the thing which is dissolved in usually comes as a denominator, ठीक है. And the third good thing to remember is whenever if they give you an identity of x, ठीक है, for example वो आपको बता दें कि x क्या है, then check कि x किस पे ज़्यादा soluble है, ठीक है. So this is 40. Okay, now so x की, so if x amount goes in ethoxy ethane, ठीक है, so the concentration will be
ओवरऑल क्या बन रहा है?
क्योंकि ओवरऑल कंसंट्रेशन कांस्टेंट होगी, ठीक है, और नीचे 4 माइनस एक्स होगा, ठीक है, क्योंकि अगर x इथॉक्सी में चला गया तो 4 माइनस एक्स वाटर में बच गया, ठीक है. रिमेंबर द कंसंट्रेशन इज नॉट द सेम, सो यू नीड टू बी अ लिटिल केयरफुल. कंसंट्रेशन इज नॉट द सेम. वी हैव x ओवर व्हाट,
आपकी जितने total volume, but total volume can get cancelled out in both places though, so that's
but you have to use the concentration, right?
I understand.
No,
so,
no, this is not your total volume. Yeah, total volume will get cancelled out too.
Yeah. तो तुम करना क्या चाह रहे हो? Are you putting n upon v लगा रहे हो क्या for concentration? So
yeah, so this is 0.055 over
0.55 कर दो ना, total volume कर.
yeah, it's 55, not 0.55. That's what I was right.
0.0. You want
It's
the
5.
yeah, so you want the total volume of water and ethoxy.
ठीक है, this is
right?
concentration, okay, ठीक है, this
Yeah.
is 40. This cancels out. X over 4 minus x. It's 40. If I done the calculation correctly, you get 41. You get 4 minus x is 41 over 4.
Yeah, तुम क्या mentally कर?
4 over 41. Yeah. So x has to be 4 minus 4 over 41, whatever that is.
Have you done the mental math? क्या सही से? 160. That's what it is. Is it
Yeah, I've done. Yeah, bolo.
Okay. So basically, I don't know how you done it, but मेरा वैसे आंसर तो 3.9 आ रहा है.
Yeah, just do this, you'll get 3.9 times.
Yes.
Okay, so if you do, now you do again, do it twice, ठीक है? So first portion में आप करोगे, so if x goes here, then 4 minus x remains, ठीक है? But this x is in, yeah, the concentration is still 0.525, yes.
Yeah.
Over 4.525. That is 40. Solve for x, yes, and now you get the same x, I think. Right?
The concentration just cancel, right? The volume just cancels, so that shouldn't matter. So the x would be the same. So the total volume is the same.
So what do you get? What do you get?
What do
you get for x?
3.9.
3.9. One more decimal place.
4 minus 4. 3.90 in fact. 3.9024 आ रहा है, तो 3.90 ले लो. 2 हो गया.
ठीक है. फिर दोबारा करोगे KPC के साथ. 3.902 निकल गया, right?
The mass of x that can be extracted from this solution by shaking with. So बचा आपका क्या? बचा तो बहुत कम ही, in fact.
Yeah, we did something wrong, Esan. You get
3.2 instead of 3.9.
You did something wrong, Esan. You did something wrong. It's a 0.05. You did something totally wrong. Now solve for x.
Lol.
Yeah, this will become 4. This will become 4.
If you simplify the concentrations, then
40, yeah. This will become 4, so this will solve to become 3.2. This will become 4/5. ठीक है 3.2. दोबारा करते हैं 0. दोबारा बता दूं कि रीजन क्या है. दिस इज x/0.025 इसके अंदर है, ठीक है, और 0.5 इसका है, ठीक है. कॉन्सेंट्रेशन व्हाट डू यू गेट एसन. सॉल्व अगेन.
solve again.
This should give you x/4 minus x. 5/8 you get 20. You get 2, 3, 3/4. 0. Probably doing something wrong. Can you check Essen, what do you get for the first extraction?
2.67.
You get 2.67.
Yeah.
तो 2.67 पहले निकल गया. अब फिर अगली एक्सट्रैक्शन में you get x/0.025. कॉन्सेंट्रेशन इसकी सेम है 0.5, ठीक है, लेकिन अब 2.67 निकल गया तो कितना बचा 1.37 माइनस x 40. इसको सॉल्व करो
1.33 basically. Yeah.
You get 0.88887. You get this time, this was 0, this is 1, 0 point. So the total concentration is the first one. This is the first extraction, ठीक है. The second extraction, what do you get? 2.67 plus 0.887, whatever that blah blah.
Yeah, they want the total amount of x extracted. Yeah. Or अच्छा, and यार सारे एक दफा जरा explain कर दो again why we're not taking total volume, why we're taking individual volume.
Total volume नहीं, this is what is happening. You have a container, ठीक है. Imagine this is a container, ठीक है. In that container you have two things, ठीक है. There's an water on top, water on top. Yeah, ethoxy here. जो वाटर में क्या होगा वो वाटर में रहेगा. You have to use the volume of water there. जो ethoxy में होगा उसके लिए आप ethoxy की concentration यूज करें.
सही है.
Yeah, this is two separate solutes, ठीक है. वो mix नहीं हो रहा है कि वो 0.55 ना.
सही. And
जो concentration इधर है और एक कुछ concentration इधर है.
And in the second part, guys, the reason why we don't use 4 in the next KPC calculation because 2.67 तो निकल गया है ना, तो मास जो बचा है वाटर में of x वो 1.33 ही है, so that's why you calculate from that.
Move on. Hopefully the last question. Okay. Why NO3 minus
ऊपर जा. Are you kidding me? Like, whoa. Clean access to clean water is critical. Imagine अगर कोई बेचारा क्वेश्चन पढ़ने बैठे पेपर में, like चलो इसमें हिंट दी गई होगी.
कुछ भी नहीं है. No useful fact. And NO3 minus is hard to remove because NO3 minus is soluble, ठीक है. State which ions are likely to get removed by the treatment of calcium limestone. So limestone किससे react करेगा? इससे react करेगा.
And barium we can be. Will barium displace calcium? It should, right? It's more reactive than calcium.
Barium carbonate. पता नहीं.
I feel that will also happen.
PB तो करता है. PB I think lead carbonate तो बनता है. These three. Let's take Essen's word for it. So
we can
get Ba2 plus Pb2 plus SO4 2 minus.
Yeah. And basically, guys, we're just looking for anything that makes it precipitate. If it makes it precipitate, वो निकल सकता है.
ठीक है.
So
Yeah, you get barium lead, ठीक है, ये दो unsoluble हैं, ठीक है, और sulfate, ठीक है. And reason is simply because you have BaCO3, that's what we said,
it's insoluble.
PbCO3,
Insoluble.
PaSO4, all insoluble, ठीक है. Nitrates and phosphates can underwater suggest what is the origin of these probably fertilizers.
Yeah, that's what
I remember.
Exactly.
ये सब AS है, ठीक है. Suggestion origin for the phosphates.
Fertilizer.
Okay, no, this is
दोनों में.
Yeah, wait, fertilizer. Anything you can think of fertilizer. What effect do this is
eutrophication. So excessive enrichment of water, just all the मसले होते हैं सारे.
I think best just one word will do. Acid rain can have a magic impact. Magic impact. Write equations to show acid rain from sulfur dioxide.
Do you have to show the cat? नहीं. सवाले पहले SO3 में जा नहीं, अच्छा, from sulfur dioxide ही बोला गया है. Okay, सही है.
And you get H2 equations. यार एक ही नंबर होगा, बताओ. Name another major industrial source.
Yes, सवाले या तो do you want to write properly? अब SO2 to SO3 जाओ and then you dissolve. Yeah. So let's draw the proper catalytic equation where NO2 is acting as a catalyst. Although
SO2 plus O2, this 2, this becomes 2, SO3.
Yeah, लेकिन ये realistic तो नहीं है ना, मतलब.
क्यों?
You know, but the proper equation is where NO2 acts as a catalyst, right?
You don't have NO2 वाले ना?
है नीचे.
Okay, the proper one is NO2.
Or I mean, yeah, I'm sure you don't need to, but like, yeah, चलो खैर.
चलो, on Essence request, I'll write down those equations.
वो नीचे लिख दो ताकि review हो जाए.
NO2 plus SO2 NO SO3
and नहीं पहले NO को कर लो. NO plus वाले.
हाँ, आदत में.
नहीं. Why just. So the idea is NO2 remains unchanged. The second step normally happens after the we've kind of mixed care, whatever.
ये लो यार, खुश हो जाओ. Name another major industrial source of sulfur dioxide.
किससे बनता है? आप जलाते हो चीजें?
Burnt sulfur.
Flue gas.
Yeah. Flue gas.
तो बेसिकली आपको नजला होता है जब आप छींकते हो.
No. It's extraction of metals from sulfide and roasting sulfide ores. This is burnt sulfur, bhai. Burnt sulfur. Or how else you get sulfur dioxide? Burnt sulfur.
So major industrial source because they want major ones.
Roasting sulfur.
So when you roast your friends.
Yes.
Oh, shukar. And finally, Khuda Hafiz.
This is